So we'll see now collector to base bias. Okay, we are seeing different kind of biasing for transistor. So the next is your collector to base bias. Collector to base bias. Okay. So collector to base bias, that means now you have a transistor, you have plus VCC here, this is your RC, and one resistance is coming here, and then this is connected to R base RB, and this is again grounded. Ammeter is again grounded. So now RB is not coming directly here, it's coming from the collector. That is why collector to base bias. NPN transistor, common emitter mode. So this is your base, okay, and this is your collector, and this is your ammeter, okay. Now, what is the advantage of this biasing? Okay, this biasing is also giving forward bias to here and reverse bias to this junction, okay. So because minus plus, so this junction is reverse bias, and this is plus with respect to the ground. So this junction is forward bias. So now let us see what happens, how this biasing is better than fixed biasing. Okay, still not a commercial biasing, but it is slightly better than your fixed bias, because always we see the circuit which keep the balance, keep the watch on IC. Okay, well, the circuit should be like this, that if temperature increasing and IC gets unstabilized, so IC get changed, there are changes in IC. So circuit should keep some control over IC, so it should not go beyond our operating point or operation region. So here, suppose you say my temperature is increasing. Okay, if temperature is increasing, what will happen? We'll discuss this one in detail. Temperature increases, T is increases, temperature is increases. Okay, so automatically my IC will increase. Okay, so there will be increase in IC, increase in IC. Now this IC, when IC increases, okay, then what happens? What happens? The voltage drop again. Voltage drop across this RC will also increase. Okay, so if IC is more, this drop is also more, because IC is coming from here only. Okay, of course it's getting divided here. Oh, sorry. So IC is what? IC is basically once it is divided. So this is your okay. So this is your division is here. This division here, and this is IC basically after getting divide. Okay. So let us see now what happens. So now temperature increases, IC increases. Okay. And if there is an increase in IC, tell me what should increase? If there is an increase in IC, okay, then what should increase? So here the total current is coming here, IC plus IB. Okay. Now if only IC increasing, automatically this IB decreasing. Okay. So if IB decreases, this drop will also decrease. Okay. And this drop decreases. Let me check it again, whether I plotted a circuit correctly or not. Whether I'm doing this fixed wire or something else. So correct, correct, correct. So now your temperature is increasing. Temperature is changing IC. IC increasing. Then this drop across resistance, because this is IC plus IB. Okay. This is also increasing. VRC. So VRC also getting increased. When drop across voltage VRC decreases, that means the point here at collector, VC, this voltage decreases. This voltage decreases. Now, if this voltage decreases, automatically the drop here also will decrease, because this voltage is coming only here and here. So VC decreases, that means your voltage across resistance RB, that also decreases. If voltage across RB decreases, okay, so this minus this only comes to your current. So your IB also decreases. So voltage across this one decreasing, resistance fixed, that means your current IB decreases. IB decreases. And if IB decreases, what happens? Again, IB decreases means what? Automatically what? Automatically your IC decreases. Automatically your IC decreases. This IC get decreases. So this circuit is basically what it's doing is controlling the effect of IC. Okay, the effect of IC. So let us see in the circuit what happens, then you understand. So now say I want to apply, say my I input loop. So input loop. So input loop is this one. So input loop means I want to apply here. This is VB. Okay, the current is coming minus VCC. I'll come from here now. Minus VCC. Okay, plus IC plus IB RC plus IB RP, and this is your VB equals to 0. Now the main thing is that input circuit, I need only the base current. So I have to change this IC. If this is the beta, I can write this is the minus VCC. I can write this is a beta IB, and this is your IB, because you only want IB in the circuit. So IB RB plus VB equals to 0. And if I solve this for IB, I'll get what? I'll get beta VCC minus VBE, okay, upon, tell me what will come, IB commons, tell me what will come, IB common. So beta plus 1 RC, okay, and then RB, this is equal to IB. Tell me yes or no. Is this correct? Circuit is, this equation is correct or not? Tell me.
Yes, sir, correct.
Now you yourself, you can see here in this circuit. If I want IC in the circuit, okay, IC just beta multiplication of IB, that is beta VCC minus VBE, okay, and beta plus 1 RC plus RB. So if now temperature changes this beta, okay, and because of beta IC increases, the beta is in the dominator also. So suppose it is increasing 5 times, beta is increasing 5 times, 2 times, 3 times, whatever times, okay, increase is there. So this IC will increase, but this beta also coming here in the denominator. So which will try to reduce this multiplication effect. Okay, it will not completely cancel out, but it will try to reduce the multiplication, this multiplication effect. Still there will be the rise in the current, but some control is there by this circuit. That's why I told in the beginning it's a slightly better than fixed bias, and you'll see by putting the values how much better is this. So now tell me.
In the circuit, we taken the current through the RC is IC plus IB.
Because IC has to go here and IB has to go here in the base. But this current should be, total current should be IC plus IB.
That is IE.
Total IE.
Okay, okay. Sir.
Because IC has to go inside and IB goes to water current going. But this current has to be sum of these two currents.
Okay, okay, sir.
Okay. Is there any student who has doubt in this equation? Tell me. Or shall I proceed?
No, sir.
Okay. Now output equation is what? You want VCE. So VCE will be what? VCE will be again IC plus IB RC, this drop. Okay, VCC minus, okay, VCC minus IC upon RC plus RB. This doubt, this is drop. Okay, now IC, what I did, IC plus IB, IC plus IB into RC. Okay, now IB is very less compared to IC, so this equation does not change, it remains the same like fixed wires. So you can simply write ICRC. So output equation remains the same. This is the input equation and this is your output equation. You know the IC, you can put value here, you can find the VCE. Okay, again same thing, you have to find for saturation, the saturation current, and you have to compare and then you have to solve the circuit. Okay, so let us solve one problem. So calculation in transistor is very simple. So VCC is given 10 volt. The question, VCC is given 10 volt and RC is given 500 ohm. Okay, RB is given 500 kilo ohm. Okay, so you need to find now Q point. Find Q point. Q point, and then also you find what you have to find the operation region. Operation region. And same time you find what is VB and VC. Always keep the habit of calculating VB, VC also. And if V is there, you calculate VE also. So that's all circuit will be in your mind. And sometime if VB goes to negative, you immediately can say that circuit will go and cut off. For VB is 0, you can say the circuit will be cut off directly. Okay. So IB becomes 0, IC becomes 0. So this time one question came from your gate exam. We'll solve that one later. So is the equation. What do you want more?
So beta value.
Beta value. Beta value is your in the question 100. Beta is 100. So IB is 10 minus 0.7. Beta is 100. You can neglect this one also. Keep RC is your 500 ohm. Okay. And RB is your 500 kilo ohm. Your IB will be what? 9.3. Okay. And this is 0.5 kilo ohm. So this is how much? 55.5 kilo ohm. 55, 40, 50, 50.5 kilo ohm. And this is 500 kilo ohm. Okay. All are kilo, kilo, kilo. This is 9.3. Okay. How much come? 550.5 10 raised to power 3. Tell me the current IB value. How much microampere?
I think 17.6 microampere.
कितना?
17.6.
17.6 है या 1.76 है? Other student, please tell me.
17.6 ही आ रहा है microampere.
17.6 microampere. चलो ठीक. Let's see. Okay. And now, how much will come? Your IC. IC will be multiplied by this one. 100. So 10 raised to power 4. So 1.76 milliampere. Okay. IC. And IC saturation. IC saturation will be what? How much? VCC upon RC, that is 500 ohm. VCC is your what? VCC is your 10 and 500. How much is coming IC saturation? Tell me. 1/50. तो कितना है IC saturation? 10/500. That is 0.02 ampere. This 0.02 ampere and milliampere. This is 20 milliampere. So IC is less. So IC is the correct IC value for this circuit. And now you can find what? You can find VCE, VCC is 10 minus IC 1.6, okay, into RC. RC is again 500 ohm, okay. So this will come 10, this is milliampere, okay. So how much come? Tell me. 10 minus 1.76. कितना आएगा? Half of this one, around. कितना आएगा? 0.8 something. How much?
0.870.
0.870. That means this is coming how much? 1.2 volt around. 9.2. Okay. Around 9.2 or 9.1. How much coming? I'm putting 9.1. Say. Is that correct?
9.16.
16 volt. Okay. Approximately you can do the correct calculation. So now you know the operating point. Okay. Similarly, now you can find a VB also. What is VC? VC is same this one. If this is VC, okay, then you can find VB also. Okay. VB will be what? VB will be your this point VC minus IB RB. That will be your VB. Okay. And V is 0. So you can do the calculations and you can find. So now it is, you can see the operation region is somewhere here. This is your 10 volt and we are getting around 9.1 volt. 9.1 volt. The current IC is 1.36 whatever milliampere, 76 milliampere. Okay, so this current is in milliampere, so it's still not going in the saturation, it's not microampere. So we can still say that is the operation region is active, but it is very close to the cutoff region. Okay, you can calculate the VB and you can make sure the VB should be greater than 0.7. Whether it is greater than 0.7, check it. So VC is your 10. VC is your 10. IB is how much? IB is 17.6 microampere. And RB is your 500 kilo ohm. Okay, kilo ohm, 10⁻3. So tell me how much coming, how much it is coming your this difference. So this difference again, it comes same like here only. Okay. So yours is milliampere, this is microampere, 17.6. How much coming? Tell me.
1.2.
1.2.
No, total answer.
Yes, sir.
Yes, sir.
After
1.2.
subtraction, 1.2.
Okay, ठीक है. If it's coming 1.2, then it is greater than 0.7. So still this distinction is forward bias and can find the values. Okay. So there's nothing new. All problem will be similar. Okay. Now I'm giving you the same question which I gave you yesterday. Okay. And now you will see little bit improvement compared to the fixed bias.
Sir, how to find Q point?
Q point is VCE and IC, na? VCE and IC is Q point.
VCE and IC.
Yes. This is this graph is IC versus VCE. VCE. So VCE come 9.1 volt and IC come 1.76 milliampere. This is your Q point.
Okay, sir.
Now the same circuit I'm giving you RC value 2 kilo ohm, okay, RP value 300 kilo ohm, okay, and you can neglect VB, you can take VB 0, and I'm giving you beta 1 equals to 50 and beta 2 equals to 150, okay. Both the cases you would find the ratio of IC2 versus IC1, okay, and it's the same question yesterday we've done, and you can immediately see what is the ratio will change, because yesterday if you have calculated IC2 by IC1, it was come ratio was 3, it will come slightly less than 3, or maybe it will come around 2, okay. So you can say this circuit has some control of changing beta, okay. So if beta becomes 3 times, current will not become 3 times, current will only remain 2 times. So slightly better circuit compared to your fixed bias, okay.
Sir, this is IC2 upon IC1.
Yes, IC2 upon IC1. होमवर्क सारे बच्चे कर नहीं रहे, भी अगर एक ही तरह का प्रॉब्लम्स आई विल रिपीट हियर, then you will miss other circuits, okay, because here class we have time limitation, okay. If a similar problem I do again and again, then new topics, new problems will not be covered. So please do your homework, okay, and then your doubt you ask. So let us do the next thing, ammeter feedback bias circuit. Ammeter feedback bias current. Only 1 or 2 students are sending. Circuit, ammeter feedback bias circuit. So this is your plus VCC, okay. And then you have the same like what we have done for fixed bias circuit. I'm keeping RP here. Now this time I'm just putting a resistance here. Okay, this ammeter, I'm putting a RE here. So this will slightly better than earlier. Okay. So let us find the input equation. You want input equation and you want output equation. This is your IC. So input equation again minus VCC. I'll this the loop minus VCC plus here current is flowing IB. This drop will be IBRB. And this drop is VPE plus VB equal VB, and then now here this resistance also there. So here ammeter current is flowing. So here current is IE. Okay. So plus IE RE equals to 0. Okay. Now I want only IB in the circuit. So you should remember IE is equal to what? IC plus IB. And IC is beta IB plus IB. So I can write instead of IE, I can write beta plus 1 IB. Okay. This become minus VCC plus IBRB plus VB, and this will become beta plus 1 IB RE equals to 0, and now your IB will become VCC minus VB, okay, and you have a RB plus beta plus 1 RE. IC will be your beta IB, okay. Again your VCE, okay. Now this equation VCE changed. Now you will have a minus VCC plus this current is IC. Now current resistance IC only, because this current is coming here, so same resistance current is same. Okay, here current is not I, current is IC. So IC, RC, then you have this voltage drop VCE. Okay, this will be VCE. Okay, and then you have IERE equals to 0. Now because here your IE is almost equal to IC, you can keep here IC, so this will be minus VCC plus ICRC plus VCE plus ICRC equals to 0. And now you can find the value of VCE. VCE value will be VCC minus, okay, IC into, tell me, what? RE.
Yes.
ICRC plus RE is the formula for, now formula change, and now formula of IC saturation will also change. For IC saturation, always put VCE equals to 0 in the output circuit, okay, load line. And now your IC saturation will become how much? VCC upon
RC plus R.
RC plus RE. This is the new formula for this circuit. Saturation. दिख रहा है ना वो? IC saturation. Or IC saturation. IC saturation. So now here this VC and VE are different. Okay. So now for this circuit, find the operating point. I will give the values. You
So
can-
just wait.
Okay. Let us give values.
Yes, sir.
So VCC is given 6 volt. RB is given 10 kilo. RC is given 75 ohm. And RE is given 100 ohm. Okay. So find the IC and VC. Find Q point. Q means VC and IC in the circuit.
And beta.
And beta value is given in the question. Beta 50. Beta is 50. So you have to find what? This you will find, and same time you have to find VC, VE, and VB. These 2 point also you have to. So let us solve. First, you want to solve, find IB. So IB is VCC minus VB. Okay, and you have RB plus beta 1 plus RE. 6 minus 0.7. 0.7 is given. 0.3. This time take 0.3. Maybe take 0.3. Maybe take 0.3 for this question. You can take 0.7 also, but then I don't have answer, so matching will be difficult. Okay. And RB is what? RB is given 10 kilo. Beta is 50, so 51 into RE is again 100. RE is 100. So this become 5.7. This 10 kilo ohm, and this is how much? This is 5 kilo ohm. Okay, 5.1 kilo ohm. So this become 15.1 kilo ohm. How much is coming? Tell me, IB.
542.3 microampere.
Kitna?
542.3 microampere.
5.2. 5.
No, sir.
542. 542 microampere.
Other student, please tell me. No, how it can come to
0.011 milliampere.
माइक्रो एम्पियर में बताओ ना. ये 57 डिवाइड बाय 15 कितना आएगा? 3 पॉइंट समथिंग आएगा ना ये तो. 3 और 4 56
37.7
37.7. Yes, sir.
37.7
माइक्रो एम्पियर.
microamperes.
And now IC will be your 50 into 37.7 microampere. Okay. How much in milliampere? How much it will come? Tell me. Less it will come. How much milliampere coming? Some 17, 18 milliampere. How much?
18.
18 point how much?
18.85.
85. Okay, please check the calculations. Okay. So if it is a suppose beta is 100, then this is come how much? It will come 3. No, if beta is 100, then 10 to the power this become 3.7 3.7 milliampere. So now if half 1.8 should come na 1.8.
Yes, sir.
1.8.
8.85.
Okay, I'm just keeping like this. You tell me the clear.
Sir, I'm getting 0.37 milliampere for that IB.
IB point.
0.377 milliamperes.
How you just check the calculation? No? Tell me how it will come.
So I've already checked multiple times.
This is 6.6 minus 0.3 is 5.7, correct?
Yes.
Yes,
And
sir.
5 points, and this is this 100 multiply this 5,100 ohm, that is 5.1 kilo ohm. 5.10 15.1 kilo ohm. Now divide 5.7
51
by
आएगा sir only.
कितना आएगा?
Only 51 into 10 is power 3 आ रहा है नीचे.
हाँ 15 ये आ रहा है ना?
Only 15.
Only
So you are written 1.
15.1 आएगा ना भी? 51 आएगा. ये कितना है? ये 5.1 किलो ओम हो गया.
Sir,
Five-
right. 0.377 milliampere.
Yes, this is correct.
Yes, sir.
हाँ, और ये कितना आ रहा है?
1.88.
88 milliampere. Okay. Now just find the IC saturation. So obviously circuit में IC is less than IC saturation, so it will not change. Okay. Now you have to find VCE. VCE will be what? VCC 10 minus IC. IC value is 1.88. Okay. Please, others also check the calculation. I'm believing on you and doing calculation according to this one. Okay, slightly change maybe there. So 1.88. Okay, then you have RC plus RE. RC was how much? RC was your 75 ohm. Okay, 75 and 100. 75 plus 100. Okay, this is 10 minus 1.88 to 10 is called minus 3. This is 175. Okay, tell me how much is coming VC. much coming VC?
Six point seven one.
6.71. How it can come 6.71? Total VCC is 6 volt. VCC is how much? 10 volt. Oh, it's 6 volt. It's 6 volt.
Sir, sir,
2 point something कितना?
sir, IB 0.377 आ रहा है, माइक्रोएम्पियर आ रहा है
0.3
0.377 माइक्रोएम्पियर।
micro ampere.
ये सर
37
ये
37 नहीं आ रहा है. हाँ?
37 नहीं आ रहा सर कंफर्म।
अब प्री कैलकुलेशन तुमको करना है.
यस सर।
फाइनल आंसर निकाल के बताओ मुझे कितना आ रहा है. What is final answer? You just tell me the answer, okay? IC and VC. The answer what I have VC equal to 2.69 volt. So that may be wrong also. Some student has done.
और IC 18.85 आ रहा है।
I see 18.885, correct. So what answer I have, I'm keeping putting the answer. You just do the calculation. IC I have 18.5 milliampere. You may have something else.
Yes sir.
I have this one, and VC I have 2.69.
So,
Yes, tell me.
so for this VCE, we have to subtract like IE times RE also, na? VCE.
So that's why is instead of
Okay,
I I'm keeping RC. I instead I'm keeping IC. I
Okay,
and
sir.
IC are same, na?
Okay, sir.
Please don't confuse. इसमें calculation में mistake मत करो इसका. ठीक है? Okay. So this is your circuit. Okay, I'm giving you one homework. You have to do homework also with this circuit. I'll give you answer also. You can check. So this same circuit, I'm giving question. VCC is 15 volt. If you don't solve the problem, then there is no meaning. Okay. After some time, whatever you learn, you will forget. RC is 900 ohm. RE is 100 ohm. Beta is 100. BB is 0.7. Okay. And you have to find the Q point. I'm giving you answer also. This is 2V at 13 milliampere. You check and tell me as a homework. Because there is nothing to do in the circuit. These are very simple circuits. If you don't practice that one also, and then there's no use, right? Because this is you don't need to do anything. Okay? Only one line circuits. You have to apply only KVL in this type of questions. And here you should not do a mistake. Okay, so you have to find this one. You have to find VB, VC, and VE also. And send me the homework. I'll check this one for everyone. Everyone should give me this homework. Okay. Otherwise, I will repeat tomorrow this one, and then you will lose the time. Okay. So.
सर
हाँ.
सर ये कलेक्टर टू दिस बायस के बाद हमने इसको इंट्रोड्यूस क्यों किया, मतलब रीजन क्या था इंट्रोड्यूस करने का इसको?
अब इसमें बीटा you can change the beta value. Suppose beta is 100. Okay.
Yes sir.
Now you just keep beta 300. Okay. And see how much IC is changing.
Yes sir. I see how IC can change.
IC to IC how much changing. Okay. So you can check whether it's better or bad. Okay. Because आपको चेक करना पड़ेगा करके कि कितना रेशियो आ रहा है. So which is better, which is less dependence on beta. Okay. So now I am going to do the circuit which is independent of beta, which is commercially used. Okay. So these circuits just for calculations. Okay. The commercial circuit what we use for the biasing circuit is the voltage divider bias, which is independent of beta. Okay. So let us know which is most important for exam also, voltage divider bias. So we will mainly practice for this one, voltage divider bias, but you should know the solving the circuit for every kind of bias. So voltage divider bias. This is most important. Bias. This is VCC RC. Now what I'm putting here, a resistance RB. Now working of this is very important. Is understanding how this work. RE. And you can put this as a ground. You can say this is R1. Say this is, you can say this is R2. Okay. And this is voltage divider bias. Now this circuit can be solved two ways. Okay. Both the way we learn and both the way value, both are almost equivalent. Okay. Very slightly difference will come answer. So one is called approximation method. Approximation method. And second is called accurate method. Now first we'll start with the approximation method. Approximation method says that because of this source, you are getting some current here and some current is going here, IB. Here current is going I. Suppose I current is coming from here. Some current is going here and remaining current is going here. But because this resistance is depending on the resistance value, if I consider this IB is negligible, suppose this current is coming in milliampere, whatever I is coming, and this IB is 20 times less than this I for roughly. Okay, if your IB is 20 times less than total I20, it is roughly. Generally, it is in microampere, is very less. So in that case, just to comparison, you have to find I. Then what you can do, you can neglect this IB. Okay, so neglect IB. That is, you can consider IB equals to almost 0. That means if I current is coming here, here no current is going, so all current will go here, and this circuit will complete. Okay, and you can immediately find what is the voltage drop across the resistance, and this will be base voltage. This is the base voltage because no current is going here. So all the voltage coming here, this voltage VB, okay. So I can find the voltage VB. Voltage VB will be what? Tell me. VCC, total voltage VCC getting divided into resistance R1 plus R2, and VB is voltage across R2. So this voltage I can find. Tell me, everybody understand this one? This is very important. I'm not moving if you don't tell me, no, just. This VB is given by VCC upon R1 plus R2 into R2. Palak, Monica, can you
Yes,
understand?
sir.
ये correct
Yes,
है?
sir.
Correct है सबको? Okay, I'm just applying this loop minus VCC plus I into R1 plus I into R2 equals to 0. Okay, this is the equation 0. Okay, so I क्या हो गया? I become VCC upon R1 plus R2, and you want to VB. VB is just I into R2. That is VCC upon R1 plus R2 into R2. This is the VB. Okay. Now you know this VB. Okay. This is VE. This is E. Here voltage is VE. This voltage is VB. This is same VB. And here voltage drop is VBE. So VBE is what? VB drop is VB minus VE. Okay. Now VB you know. VBE always you know 0.7. So my V become what? My V become VB minus VBE, built-in potential, because this base voltage only provided forward bias to here. So this will be consumed here and here, and this is what? This is VE. So if you can find the VB, automatically you can find VE. Okay. And if you know the VE, you can find the IE flowing in the circuit. IE will be what? VE upon RE. Yes or no? And if you know the IE, I is almost equal to IC. So you have calculated IC without knowing beta. What is the beta? No dependence on beta. Okay. Beta is not beta is not coming anywhere in this circuit. It's not affecting. So you know the IE, IC, IC you know, then you can find VCE. VC is what in the circuit? VC again the same circuit, output circuit the same like earlier circuit. VCC minus IC RC plus RE. So all the circuit is completed, okay? Because you itself considering, now I'm not calculating IC equal to beta IB. Okay, I'm just finding that this voltage is independent of your this one. So if you know this VB, okay, you can find this VE, and if you find this VE, you know this IE. Okay, if V is this is fixed and this is fixed, this is equal to IC. If you want to know IC, you can find the VC. So this circuit becomes very simple. Now, just to have a check whether this assumption what we have done is correct or wrong. Okay, maybe IB is not negligible. So just now you know the IC here. You can do back calculation of IB upon beta, IB equal to IC upon beta. Calculate the value of IB and check and compare this IB with a total I in the circuit. If this is negligible compared to this one, or this is 20 times less than I by 20, you can say our assumption is correct. I can always neglect the IB. Tell me, if this point is clear to everyone?
So please repeat once again. The last point.
Last point is says, you find BP is simply given, you got BE, you know VE, you divide by RE, you got IE, you know IE, you got IC. If you know IC, you can do back calculation of IB. The IC is equal to beta IB, you can find the IC. Now you know this value, okay, and you know this current also, okay. Compare this
Yes.
IB with this IE. If it is 20, you divide I by 20, and then also it is less than this one IB, okay. Then you always can say na, that suppose this is coming, I is coming 100. Now 100 divided by 20 is how much? 5. If your
Yes, sir.
your IB is less than 5 also, then you can say my assumption is correct. Compared to this one, this current is nothing, so I can neglect.
Yes,
Clear?
sir.
Clear? That's the only thing. So you can neglect IP. Now, so we'll do a lot of problems of this circuit. So let me start with one problem. Your VCC is given 10 volt, RC is given 3.6 kilo ohm, beta is given 150, but you don't require beta here. Just to back calculation, IE is given 1 kilo ohm. Okay, R1 is given 10 kilo ohm, R2 is given 2.2 kilo ohm. What do you want more? VB is 0.7 volt. Okay, and you have to find the operating point. Okay, you have to solve this question by approximation method. Okay, solve it by approximation method. Solve using approximation method, and later we will do with the accurate method also. We'll see how much it is coming. So again, first thing is you have to find the VB. Okay, and VB, you know what is VCC upon R1 plus R2. Neglect IB. VCC is 10. R1 plus R2 is how much? Tell me. 10 and 2. 10 kilo ohm plus 2.2 kilo ohm. 2.2 times
12.2
10, 12.2
kilo ohm.
kilo ohm. Okay. How much milliampere coming? Tell me.
सर मल्टीप्लाई में R2 रह गया ऊपर.
R2 कितना है? 2.2.
Yes sir.
2.2 kilo ohm.
1.80 आएगा वोल्ट VB.
कितना?
1.8 volt.
1.8 volt.
Yes sir.
Check it. So yes, 1.801 volt. Okay. So 1.80, I am taking 1.801 volt. Okay. Correct?
इतने ज़्यादा है.
Now you know the VB, you know this one. Okay, you can find what VE. VE is coming from VB. VB minus VBE. That is 1.801 minus 0.7. Okay. So around 1.1 volt.
1.10.
Okay,
3
1.10, 1.1 volt ले लो ना. 1.1 volt is, but time से you have to do accurate calculation. तो exam में otherwise sometime range will be given na. Okay, so whatever. So 1.101 volt, correct?
Yes, sir.
And now you can find the IE value. IE will be 1.101 volt divided by RE. RE value is 1 kilo ohm. 1 kilo ohm.
So,
Ah,
so here VB is VCC times R2 upon R1 plus R2, na?
okay, VB equal to R2. R2. Now this will be how much? This will be 1.101 milliampere. And this I can take equal to IC. Okay. And if you know the IC, you can find the VC. VC will be 10 minus IC 1.101 milliampere into RC. RC कितना दे रखा है?
3.6 into 10 to the power
3.6.
3.
So 3.6 kilo ohm plus RE 1 kilo ohm 10 to the power 3. Power cancel. So VC equal to 10 minus 1.1 into 4.6. कितना आएगा? सॉल्व करके बताओ पूरा. VC कितना आ रहा है टोटल?
4.94. 4.94 आ रहा है कुछ?
हाँ, मतलब फाइनल आंसर बताओ. VC कितना आ रहा है? VCE 6.04.
Yes sir. इसमें भी घटा है.
Is that n minus this something 4 point something आएगा? 6.04 answer I have. नहीं चेक बताओ. VC में नहीं 4.94 4.94 और 74. VC आई है
4.9.
4.9 4.94 whatever volt.
4.
This answer. VC. Okay. Now can you find, if you know the VC, can you find VC? So VC you can find this point VC in two ways. VCC minus ICRC, or you can also find, you know, VCE. So VC minus VE is equal to VCE. Okay, you know VC, you know VE, you can find the VC. So either you find like this or you find like this. You can find the VC also in the circuit. Okay, so I'll stop here. But this is very important biasing. So इसके क्वेश्चन हमको थोड़े ज़्यादा करने पड़ेंगे. Okay, because most important यही है. So we'll continue this tomorrow. So I'll stop here. Thank you.
थैंक यू
थैंक यू सर
सर
Hmm.
Thank you, sir.
सर सर मॉड्यूल कैसे फॉलो हमें सॉरी हमें
Hmm. बोलो.
हाउ टू फॉलो मॉड्यूल हमें क्वेश्चन कैसे करने हैं समझा नहीं मतलब आपने बताया नहीं एक बार भी
कौन सा क्वेश्चन?
अरे जो हमें मटेरियल दिया हुआ है उसको फॉलो कैसे करना है
उसमें मेनली आपको प्रीवियस क्वेश्चंस करने हैं. प्रीवियस क्वेश्चन है ना, जेस्ट गेट के, नेट गेट, ईएफआईआर के वो देने हैं. और जो बुक के अंदर कुछ एग्जांपल्स दिए होंगे वो देना है. और ट्रांजिस्टर के लिए सबसे जो अच्छा तरीका है सॉल्व करने का, प्रीवियस करना ही है. आपको बॉल स्टेट की बुक है ना सबके पास में?
ये सब पीडीएफ है
हाँ, वही उसी बुक में ट्रांजिस्टर काफी क्वेश्चन दे रखे हैं, उसको सॉल्व करना है. तो पहला काम तो जो क्लास में कराना है क्वेश्चन वो करने हैं. उसके बाद
Yes, sir.
प्रीवियस के सारे क्वेश्चन करने हैं. ठीक है. और जो मटेरियल में दे रखे हैं एग्जाम्पल, और फिर बॉल सेट की बुक है. क्योंकि इसके अंदर बहुत ज्यादा प्रैक्टिस की जरूरत है नहीं, क्योंकि इतने सिंपल कंसेप्ट हैं. आप एग्जाम में इसको क्यों गलत करोगे बताओ? अगर आपको सर्किट सॉल्व करना आता है, ऐसे ही चेंज होगा. बस आपको क्या वीबी निकालना पड़ेगा, वीसी निकालना पड़ेगा, वी निकालना पड़ेगा. सर्किट कुछ भी आ जाए, इफ यू नो हाउ टू डू इट सर्किट, ओके, देन आई डोंट थिंक ट्रांजिस्टर क्वेश्चन गलत होना चाहिए. फिर भी वो प्रैक्टिस के लिए प्रीवियस से क्वेश्चन करो, आप प्रीवियस से क्वेश्चन करो. और अभी यहाँ पे तो काफी क्वेश्चन करेंगे, हम क्लास में करेंगे अभी ट्रांजिस्टर के. तो ठीक.
ओके सर थैंक यू
थैंक यू सर